Hello and welcome to another creative coding video. Today we're going to be introducing a brand new topic on something called noise. I'm really excited actually because it's something that's really cool. It's actually really powerful and you can do some really interesting creative things with it. So let's get started. We're looking at what looks like a landscape and you can see the horizon over there going down, up, along, down, up and down, and we can ask ourselves, well, how do we write code that draws this this horizon that seems to go up and down? And we can start off by thinking, well, it's the height of the land in some way, the kind of the altitude, the height above sea level in some sense, and it's not a smooth mathematical function. It's not like a wavy sine wave that we've seen before. It's not a straight line. And if we looked at different examples of different landscapes, we might see some that were perhaps a bit more craggy and some were a bit more smooth. But the idea that it's random does seem right. That seems to be a good starting point. Are these landscapes going up and down in a random way? Let's experiment with that. Let's use that as a starting point. So let's write some code. So I'm already logged into Open Processing. I've enabled my Simple.js library. The latest update to Open Processing has a default option called Show Frame, which is on by default. And it just means it draws a frame around your canvas, which I've turned off because that's what we're used to. So I'll do that. And I've enabled the simple library in the setup section. I've written a small amount of code, nothing particularly fancy or new. You'll have seen a lot of this already. So we are using red as a stroke. We know about that. I'm using a repeat instruction to repeat some code which I've called horizon. That's the function that I'm going to be repeating, and I'm using a loop counter to start at 100, go up to 700 in steps of 5, and that loop counter is going to be passed to the function and it'll be called x. So you can see that when we draw a line from x400 to x400 minus y, so x starts at 100 up here and goes up to 700, and the line is drawn from x400, wasn't it? Is that right? Yep. So starting there, that's the line from x400, and the line goes up to, so a line has a starting point and an end point. The starting point is x400 and the end point is 400 minus h, which is a random number. That's what h is. So a random number between 0 and 200. So it will be essentially a height going up by a random number. If h was 100, that's how high it would be. And remember, x goes all the way up to 700 in steps of 5, so we might have a pattern like this with random heights. They won't go above a height of 200 because that's the maximum for our random number range, and they go all the way up to 700. Let's see what happens when we run that code. Okay. Here we go. You can see that across the screen from a horizontal position of 100 up to 700, we have lines drawn upwards with a random height between 0 and 200. Let's run that again to see that it is random and different when we run it again. Yep, it's different again, different again. Now, do these look like landscapes? I mean, apart from the fact that it's red and not green, do they look like landscapes? I'm not sure they do. Why is that? Why do we think these aren't realistic landscapes, like the horizon on a landscape? Well, if we look at it and think about it, the ups and downs are a bit too exaggerated. The real landscapes don't seem to jump up and down quite so much. They tend to move more smoothly up and down. What does that mean for us? Let's look at another picture. So here's a little person on the landscape, and as this person moves left or right along the horizon, the jumps aren't too big. The ups and downs are not too big. So that means that if I pick 2 points, they are not going to be too different to each other. That's an important thing to realise. Let's draw what we mean by that. So let me draw a horizontal line to separate what we were doing before. If I've got a height up to here, the next height can't be too far down or much higher. It's got to be similar to what it was, and the next one's got to be similar to what it was before, and so on. So yep, I could go up and up, or I could go down and down, but between any two, like that one and that one, or between those two, or between those two, the difference in height can't be too big. So it's still random, but it's a more moderated kind of random. It's smoother in some sense. Can we do this? Is this random really? Is this the same kind of random? Is this a different type of randomness? What is this smoother randomness that we're after? Well, somebody invented just what we need, and the difference is often in the word that we use to describe it. So this is pure randomness, and what we will want is often called noise. Ken Perlin is the chap who did a lot of work and is considered to have invented it. He won an Academy Award actually for it, because it's so useful in the creative industries, but we'll come to that. So let's change our code. So the magic line is this one that picks the height. Now what we want to do now is use a different function that doesn't pick a random number. We want to use something called noise. Now if we ran this code, it wouldn't work, there'd be an error. And the reason is noise needs a parameter. Let's try feeding it x and see what that does. Let's run this code. So instead of a random number between 0 and 200, we're using whatever noise gives us as the height. That didn't seem to do anything. Now I've deliberately made that mistake because the best way to learn is by making mistakes. This is similar to that thing we faced when we were using sine and cosine, those wavy functions. Sine and cosine go from -1 to +1, and noise goes from 0 to 1. So a height of something between 0 and 1 is tiny when we've been used to working with a height that could go up to 200. So let's multiply it. That should scale it up to 200. So if noise came out with a value of a half, we'd have 100. Let's run that now. Well, it certainly fixed the height issue, but still looks very spiky, not very smooth. Deliberate mistake again. The reason is that noise has a scale, and we need to, depending on how we're using it, we often need to adjust the scale of the parameter that's fed to noise. And quite often we find that we're having to reduce it. So x here goes from 100 to 700. Let's divide that by 100 so that it goes, in effect, from 1 to 7. Let's see what effect that has. Hey, that's much smoother, isn't it? That is interesting. So let's look closely at that. So from a distance, it's random. There doesn't seem to be any logic to how it goes up and down. But looking closely, the heights are mindful of their neighbours, so they're not too far up and down from their neighbours. So remember before, when we had pure randomness, each height was independent, because pure random numbers are independent of any other pure random number. Now we can't have that here, because each value, each height, has to be mindful of where its neighbours are, so it can't be independent. One of these heights can't choose to be very high. It has to fit in with its neighbourhood. Yeah, so this is nice. This could be an interesting landscape. Let's run that again. Have a different one. Oh, there's a big hill in the middle. Let's try again. That's rather a smoother landscape. This has got a big valley over here. Let's change that parameter, that scaling, to say dividing by 50, so it should go up and down a bit more. Yep, we can see that. If we divided it by a much bigger number, so 200, it should go up and down even more smoothly than we've seen it before. There you go, that's much smoother. Let's run that again. So this is nice. This is a really useful function for when we want something that's random, but not too random. It's a smoother kind of random, and it's called noise, and it's built into this language, which is nice. We don't have to do anything special to give our coding language this ability. So let's move on to the next step of perhaps making something two-dimensional. Can we have two-dimensional noise? We can. If it's two-dimensional, well, let's go back to drawing pictures. Right, so if we are thinking about doing something in 2 dimensions, we could have, something like a grid, say from here to here to here to here, and we could look at all the positions along this as a grid, the pixels in effect, and we could give them a value, say a colour, which depends on noise. So it should be random, the colour of those positions, but not too random. Now the noise parameter, the noise function, will need to know where it is on the grid. Why does it need to know where it is? Same reason as before. It needs to know what its neighbours are going to be like. That's why it needs a parameter. If noise didn't have a parameter, it wouldn't know how to be mindful of its neighbours. It could only ever be purely random. So if we're working in 2 dimensions, we need to feed the noise function, 1 where we are horizontally and 2 where we are vertically, for it to know that we are here and that the value that it chooses has to be similar to its neighbours. Let's have a go at that. So let's adjust our repeat instruction. Let's make it go from, say, 200 to 600 across and 200 to 600 down in steps of 5. Noise now, the horizon function takes 2 parameters now, the 2 loop counters. Let's say we pick a colour. depending on the noise. So let me think. Are we going to use red, green, blue or HSB? I think I will use HSB. And what I'll do, so color mode, HSB, and I'm not going to use a stroke anymore because we're not going to draw a line. Let's say we're changing the saturation, sat, and it will go from 0 to 100 because HSB values go from 0 to 100. The important point here is that noise now takes two parameters, so it could be x comma y, but we're going to scale it so it's, let's say, divide by 100 there. So this noise function now is taking two parameters, we scale them down by 100, and it should give us a value that's some kind of smoother noise. I'm scaling it up by 100 to be a saturation, and I'm going to say fill, 220 is the hue, which should be some kind of blue, I think, saturation, and a brightness of 100, let's just say, and at x and y I'm going to draw a circle just to see what happens. So x comma y, size 5. Let's see what happens. I've just been writing that off the top of my head. I hope it works. So just to recap, we're using a nested loop with two counters to go over a grid. Those counters are passed to our horizon function. It's not really a horizon anymore, but yeah, let's call it it doesn't matter, we don't need to change it. X and Y, and we are using X and Y as parameters to noise, and the noise will interpret that as saturation in our fill instruction and draw a circle at that point. Let's see what happens. Okay. Yeah, there is something there, but I forgot to remove the stroke from the circle. So let's say no stroke, because that's black, isn't it? Let's see what effect that has. Hey, that's interesting. Let me make those circles a bit bigger. There, that's interesting, isn't it? That is interesting. So I have here saturation that's controlled by noise, and from a distance it's random, but looking closely it's smoother because the values aren't changing, totally independently and drastically changing from one value to the next. There is a smooth transition. So this could look like a sky, clouds. Isn't that amazing? Just a simple mathematical function, noise, and we've created what looks very effectively like a realistic sky. Let's run it again. Takes a bit longer to run because there's lots of calculation to do there. Right, let's look at another one. Yeah, those are really cool. They could all look like photos of the sky. And that's amazing given how simple our code is. Now just to contrast, let's imagine that we were using random noise, pure randomness. So I'll comment out that line that we had, and we'll say saturation is 100 times, actually it's just a random number, isn't it? Random number between 0 and 100. So we're saying saturation is a random number, pure random number, between 0 and 100, which is what saturation has as a range. Let's see the effect. So there's no pattern here, it's just like static or yeah, so that's something different. So if we go back to using our noise, you can see that the variation is smoother. That's really cool. Now, there are lots and lots of creative uses for this. We won't cover them all today. We'll do future videos looking at individual cases. You can do cool things. Making textures is one of the best things you can do with noise. Making wood-like textures, making stone-like textures. Game landscapes, game levels are made with noise. It's such a useful thing, and we won't be able to cover everything, but in future we will have little videos showing some uses of it. I'm just going to refine this one a little bit because I've done circles which are rather large. So what I'm going to do is use a point to draw a dot, and point use stroke. So I'm going to say no fill. Well, actually we don't need that instruction at all. So instead of a circle or a line or a square, we're filling in just the dot, the point, the pixel. And to colour the pixel, we use stroke rather than fill. And I'm going to go up every 1 pixel rather than every 5. So this will be a lot more detailed, but it might take a little longer to calculate. Let's see what happens. I'm going to just change how the starting vertical position from 100 to 500 because it was a little bit down, wasn't it? Let's go. Let's have a look at, wow. So this is every single pixel now coloured. Isn't that interesting? Those really could be photos of the sky. Wow. My computer's fans are blowing now because calculating something for every single pixel is hard work. Let's try a different experiment again, just to let's affect the hue, not just the saturation. And let's say it's noise at x divided by... Oh no, actually before we do that, before I jump ahead, let's see what happens if we don't divide the noise parameters so much. So these are now dividing by 10, not 100. And when we did that with that landscape, the landscape was more bumpy. Let's see the effect. There you go. So it's a lot more grainy and detailed. It's not as smooth. And if I made them very smooth, dividing it by 200, hopefully it's a much smoother bunch of clouds. There, that's a lot smoother, isn't it? I think 100 was quite a nice number. So when you're doing this yourselves, you'll often have to experiment to see what the right scaling is. Now I'm going to see if I can use noise for the colour, the hue. So this goes from 0 to 1, and I'm going to try and map it. Okay, so I'm using the mapping instruction. We've seen that before. It takes a number from one range and maps it to another range. So we know this is from 0 to 1, and we want to map it to, say, I don't know, let's say 60 to 120. It's just an experiment. And we'll change the stroke instruction to take that hue. I don't know what effect this is going to have. It'll be a surprise to me. Let's see what it does. Let's see. Oh, okay. That's interesting. So it's picking colours from a range of greens. I'm going to remove that saturation and make that 80. I'm going to keep that saturation simple. Nope. Going to remove that line, don't need it anymore. So all I'm doing now is not affecting the saturation, I'm keeping that at 80. and the brightness is at 80. I'm now using noise there, which is from 0 to 1, mapping it to say 60 to 120, just greens I think. Let's just change that to 0, so it should get some reds in there. Let's see the effect of that. So now the hue is generated by noise. Ah, yeah, that's interesting. And you won't be surprised if I told you that actually noise can be used to create flames and fire. So this is a little hint of that in a way. You do need to do more calculations and refine it a bit, but you can see how you could start with noise and make flames. Let's run that again. Yeah, that's really interesting, isn't it? So, you know, those really rich textures from just 2 or 3 lines of code. That's amazing. So you really should experiment and play with noise. You know, there's so much you can do with it. I'm going to finish off by making what I think is a nice sketch that kind of demonstrates the kind of power of noise. It is something I've kind of developed before, so I'm not doing it on the spot. It's something I have played with before, but I think it's so nice that it's worth sharing. Okay, so I'm going to have a grid again. So I'm going to have a more detailed grid going from 100 to 700 across. And I'm going in steps of 1, okay. Yep. And I'm going to have the grid going from 100 to 500. Yep, that's fine. And I'll call my function noisy dot. Noisy dot. Okay, so that will... So just to see what that's doing, let's draw a small circle at each point. Let me make that for every 10. There, that's much better, isn't it? So that's a grid of dots. And it's a grid because we've got a counter going across from 100 to 700 and a counter going downwards 100 to 500 in steps of 10 here, and I'm just drawing a circle at those points. Now let's remove the stroke of those circles so there's no outline, and let's fill them with purple. Let's just see the effect of that to make sure that works. Let's increase the size of the circles. No, let's keep them the same. Let's see. Tiny little, really tiny dots. You can't see them easily. Let's make them a bit bigger. There. Make them even bigger. Yep. Okay, so it's a grid of circles, and we've done this before, so there's nothing new here. Now, what am I going to do with noise? What could I do? I could colour the circles according to noise. We've done that before. Why don't we do something different? Why don't we move each of those circles according to noise? So not colour them according to noise, but move them from where they are a little bit. So we're nudging them. Let's see. So the circles are at X and Y, and we want a new X2, say, and which could be something. We'll fill that in a second. And a new Y2, a new position. And we want the circles to be at X2 and Y2. Now before we use noise, let's do something with pure randomness just so we can see the difference. So we can say X2 is X shifted by a random number between, say, -5 and 5. And I'll just copy that. And we can do the same for Y. So this means that the circle, the dot at X, is going to be shifted left or right by a random number, which is small. It could be in the range from -5 to 5, and similarly for the vertical position as well. Let's see the effect there. So that grid has been shaken, it's been disrupted a little bit. It's not a regular grid anymore. Interestingly, if we didn't shake in one direction, so we just said var y2 is y, as in we didn't change the vertical position away from the grid, we should get, you can see the horizontal lines. So we're now only shifting in the horizontal direction, not vertically. So the circles on the grid have only been nudged left and right a little bit. That's a nice pattern in itself. But let's go back to the nudging in both directions. So there they are, they've moved all a little bit. Okay, so that's random, there's nothing particularly interesting about that. Let's now use noise. So noise, we'll build this code up and talk about it. So we're saying noise, which depends on X and Y, and remember we scaled the X and Y. We can say, I don't know, let's say like we had before, divide by 100. So this now will give us, this noise function will give us a value between 0 and 1, and that won't really affect the grid much because it's a tiny amount. You can test it, let's run it. See, the grid still looks like it did before. The nudging is absolutely tiny, so let's scale it up. Let's say 100 times that. 100 times. Let's use brackets to keep things in order. So it looks like we're using lots of brackets, but all we're doing is we're saying X has this thing added to it. So it's noise scaled up to 100. The same thing with Y. Let's see the effect of that. Ah, that is interesting, isn't it? That does look nice. That is really rather cool. So the dots on the grid have been moved, but not purely randomly. They've been moved in a smoother kind of randomness, noise, and we can see some really interesting structures here. There's sort of, I don't know, waves in sand or something like that. Let's scale down the let's reduce the smoothness, and the way we do that is not reduce the parameters by such a big number. Let's see what effect that has. Yeah, that's a little bit more noisy. Now, the grid was spaced at, say, 10 apart. Let's now increase the granularity by making the grid even more detailed by having each point 2 bits apart. Let's see, this might take a bit longer to generate because there's a lot more work to do, but let's see the effect. So it's, there's a lot of pixels there, lots of dots there, sorry. Let's make them smaller, those little circles. That is interesting, isn't it? Can you see? That's really, oh yeah, I like that, that's nice. What happens if I do go the full whack, as it were, and do the full grid for every pixel? So the grid is now spaced 1 apart. Wow, look at that. Oh, that was really interesting. I wish I hadn't pressed rerun there. I wanted to look at that a bit longer. That is interesting. Now, there are some improvements we can do to that. And they're not essential, but I'll cover them because they might be useful for you one day. Now, let's look at noise. Noise goes from 0 to 1. And we've scaled it up by 100. That means the shift could be between 0 and 100. But when we had our random numbers, we said they could move left, move left by up to 0.5. So our randomness was from -5 to +5. But here we're only moving to the right. We're not allowing it to move left. So one easy way of remedying that is to say we just take 50. So add a noise value, which could be up to 100, but we are taking 50 from it, so that the new range could be from -50 to +50. Visually won't make that much difference, but in other designs it can make a difference because we can now move up and down, left and right, not just to the right and down. Just taking up, oh yeah, okay. Now there is another little improvement that we can do. It's a big improvement actually, and it's to do with the way we are using noise. Now let's look at our code again. If you look at this one, we're saying noise depending on X and Y, and the dot on the grid is moved in that direction. The same applies for the vertical direction. It's shifted according to noise, which depends on X and Y. And actually these two will be the same number. The shift across and the shift down will be the same because these two bits of code are exactly the same. It might make a more interesting design if these two were different. Now an easy way to do that is to swap X and Y. By swapping them, the noise generated will still be smoothly random, but picked from somewhere else, as it were, in the parameter space. But still depending on X and Y, so it still makes sense for our design. And that's a really good trick actually. It's used a lot, so keep that one in mind. Particularly if you go into, say, 3 and 4 dimensional noise. But we'll look at that another day. So let's run this code. Wow, that's a lot more varied, isn't it? It's a really interesting design that. You can see scrunching up and spreading out, and areas where there's a lot more smoothness, and areas where the scrunchiness sort of follows lines. It's almost like a tissue that's been scrunched up in some sense. And the fact that it's a little grid, I think it gives it a really nice effect. I really like that. That's really cool. Let's run it again. It's gonna, yep. Yeah, really nice actually. I think these work really well, especially given how simple the code is. Let's do one more. Really nice, yep. And, if you look at this design and think, it is interesting, there is lots of detail to explore, and then when you look at the code, all we've done with a few tiny lines of code is we've used a grid to draw dots, and all we've done is displace the dots from where they were by a tiny amount, which isn't purely random, is smoothly random using Perlin noise. And that's all we've done. magic. Let's have a look at another one. It's addictive. Nice. One more before we finish, because I just find this too fun. It's taking a while because it's quite a lot of calculation to do. I really like those. I mean, yeah. Look at those. Really nice. Yep. We'll stop there. I won't carry on, even though I'm tempted. Have a play yourselves. Use noise to generate color, to generate movement, anything else you can think of. It's such a useful function where you need randomness, but something that's a smoother kind of randomness. I really recommend it. I mean, one thing you could try is having an object like a dot and just moving it around the screen and leaving a trail. There's all kinds of things you can try, but I'm really pleased that we finally got to looking at noise. It's such a powerful, useful thing, and we will have more videos exploring how we can use it to do things like textures or landscapes. I've got a couple really interesting examples in mind, so do come back and have a look at those. Okay, see you next time. Bye.